Hello. Let's do a problem on centroid of an area. Find centroid of the area shown, the area that's between two functions, y sub 1 and y sub 2. Centroid x bar and y bar. X is the distance to y-axis, distance of centroid to y-axis, and then y is distance of centroid to x-axis. Remember, these are opposites. So if the centroid is somewhere kind of right here, this will be the x bar, and then this will be the y bar. So that's what we want to find. So let's look at this one. Let's just start with finding k and m in this figure. So when let's look at y first function, y1 equals mx. When x equals 0, y1 is 0. When x equal a, y1 is b. So let's use this one. The first one doesn't help us much because we get 0 equals 0. This one will give us b equals ma. So as a result, m should be b over a. For y2, y sub 2, the second function, k x to the power of half. Again, when x is 0, y2 is 0, doesn't help us much. When x is a, y2 is b. So let's use this one. B equals k a to the power of half, or square root of a. So therefore k equals b over a to the power of half. All right. Next, let's write the equation for centroid. For y bar, we have y tilde dA. Some books might write that as y bar as well. That's okay, over integral of dA. And then x bar or x bar, this way, integral of x tilde dA over integral of dA. So we'll talk about this. So some stuff we got to find. We got to find y tilde, we got to find x tilde, and we got to find dA. So before I go over what each of them means, let's draw an elemental section of the area, or an element, a small element of the area. I have here B, then I have here A. So I'll take a small element of area, this area. If I want to find this area, if I add these really thin elements of area all together, in other words, adding in this case means integration. If I integrate this little element of area starting from 0 all the way to a and add them all together, that should give me my my area. The width of this little element is very thin. It's differential amount of x, because it's on the x-axis, and the width of it, the width is dx, the length of it is, this point is y2, this point is y1, so this length here is y2 minus y1. So if I want to find this area, this is my differential amount of area is width multiplied by length, so it's y2 minus y1 dx. I can replace each of the functions to get a better equation here, and that will be, if I replace also k and m with b over a and b over square root of a, I will get b x over a minus x over a dx. This here is y2 minus y1. All right, so now I can kind of define what's y tilde and x tilde. Y tilde is distance of centroid of dA to x-axis. Okay, in this case, this is a rectangle. My dA is a rectangle, so centroid of it located at the middle. This is y tilde, which in this case is y2 plus y1 over half. X tilde is distance of centroid of dA to y-axis. It's a very, very thin rectangle, so center of it is located at just x. So in this case, this is just x. So I found dA, x tilde is x. All I have to do is let's find this based on also x and dx, and then we can start doing integration. Here I have redrawn this here previously, so all I have to do here is let me remind you of dA here quick. Dx, x tilde was x, y tilde is y2 plus y1 over 2, which if you do substitution, you are going to get b2 x over a to the power of half plus x over a dx. Oh, I'm sorry, there's no dx. All right, with this we are going to start doing the integration. So first one, let's do integration of dA. So integral of dA, let's replace this equation here, b x over a minus x over a dx. I have dx here, so that means my bounds of my integral, the limits of my integral is going to be x1 equal to something, x2 equal to something. Okay, so this integration over this area, it starts, my x starts from 0 and goes to a, so 0 to a, and that's how I figure out limits of my my integral. If you do the integration, you will end up with b is a constant. We will take it out of the integral. X is to the power of half, so will be 1 over 3 over 2 x to the power of 3 over 2. I added 1 plus half, so 3 over 2, 1.5. And then a, again, constant number stays where it is. x becomes x2 over 2, and then a stays where it is. So do the integration. This b is into all of these, and then it goes from 0 to a. If you do the replacement of a, you will get b 2 over 3 a 3 over 2 a 1 over 2 a squared 2a minus 0, you don't, all zeros. This will result in ab over 6. This is the area, ab over 6, the entire area. All right, a integral of dA is ab over 6. All right, now we got to do the integration y tilde dA. Integration of y tilde dA, I have to replace y tilde, which is this one, star equation, and dA is this one. So all I have to do is put both of these into integral. It's going to be b over 2 x to the power of half a to the power of half plus x over a. This is my y tilde, multiplied by b, and then my dA is pretty much the same thing, except this is a minus sign, and dx. Again, I have dx here, so my limits of my integral are also going to be x. Again, this is an area, goes from 0 to a, so it's going to be 0 to a. Let's simplify within the integral a little bit before starting to integrate. B over 2 and b, that becomes b squared over 2. It's a number, it's a constant number, so we'll bring it out. Bring it out of the integral. Limits are going to be 0 to a, and if I do the multiple, you know, this is a plus b multiplied by a minus b. So I will have, this will result in a2 minus b2. So as a result, I'm going to have x over a minus x2 over a2. Much simpler, dx. All right, so my integral are going to be b2 over 2. I'll do it a little bit faster here. Please pause and do it yourself if you would like to do the math a little bit slower. 0 to a. As a result, this is going to be 1 over 12 a b squared. Okay, please do the x tilde dA by yourself. I'll give you just the final answer for it. If you want to check your answer. So going back to our two main equations we had, y bar was integral of y tilde dA over dA. So as a result, this will be 1 over 12 a b squared over 1/6 a b. This one just will be b over 2. And then x bar, x tilde dA over dA, it will be 1 over 15 a squared b over 1/6 ab. This will result 2/5 of a. So the centroid, the y bar is exactly middle of the b. So somewhere over here, that's the y bar. So x bar is 2/5 of a. It's a little bit less than half. So if this is half of a, we're looking at somewhere kind of right here. So this will be the centroid of this area that we have. Thank you. Let's look at another centroid problem. Find the centroid of the area shown, the shaded area. Again, this one, y bar, which is distance of the centroid to x-axis. Let's say this is the centroid. This will be y bar, and then x bar, or if you want to use capital X bar, will be the distance to y axis. Remember, these are opposite of each other. So this will be x bar. So the problem is asking find the location of centroid, location of this point. First thing I like to do is find this k based on a and h. You might have a problem very similar to this, that h and a are numbers and given values to you. I think it's better to do it this way, parametric, and then you can just substitute any number you want. So let's look at it quick. When x equal a, this point, y, well, we don't know what y it is, or y is it. So let's see. When x is equal to a, so this point, then we know y is h. So let's replace or substitute these into y equal kx. So h equal k 2a. Let me write it here better. H equal k 2a squared. There we go. As a result, k will be h over 4a squared. All right. So for these problems, we always draw a little element of area. Okay, so I'm going to take a little element of area, a little sliver, a little rectangle here, and the integration is putting infinite number of these rectangles next to each other. Add them all up and see what you get, and that will be your area. So this is very thin, and it's d x, and then the height of it is just y. So my y bar, this is just centroid equation, is y tilde, or some books notes it as y bar, dA over integral of dA, which is total area. X bar is x tilde dA integral of dA. I'll talk about what each of these mean. Y tilde is distance of centroid of that little element to, this is y tilde, so it's to x-axis. Centroid of this element, this here, it's a rectangle, so it's going to be the center of it. This is y tilde. And then distance of centroid of it to y-axis is going to be my x tilde, which in this case is just x. In this case is half of y2 is my y tilde. So it's y over 2 if I replace the y with the equations I have, is h over 8a squared x2. K I calculated here, and that's my function. X tilde is the distance, as I mentioned, of centroid of dA to y axis, which in this case is just x. And then dA is that differential area, so I have dx multiplied by y, so it's y dx. Let's plug y in here right away. So it is h 4a squared x2 dx. All right, so I have these three. All I have to do is plug them into the integral and do the integration. Let's do y. Let's do y tilde dA. If I replace it, it's going to be h over 8 a squared x2, that's my y tilde, and my dA is h over 4 a squared x2 dx. Looking at limits, I have dx here, so limits of my integral are going to be x1 to x2. My area starts from a, goes to 2a, so a to 2a. If you do the integration, you will get h2, and these are numbers, they can all come out, 32 a4 a to 2a, and then all I have left is these two, x4 dx. All right, very manageable. So h2 32 a4 x5 over 5 going from a to 2a. If you plug a and 2a on here, you should get 31 over 160 a h2. Let's do x tilde dA. That's the next one I want. X tilde was just x, and dA was h 4 a squared x2 dx. I have dx, so bounds of my integral going to be x again. x1 goes from a to 2a, same as before. This will result in h over 4a2 a to 2a x3 dx. Again, very manageable. So this will be h 4a squared x4 over 4 a 2a. If you do, oh sorry, this is not integral, just from a to 2a. If you plug a in there, you get 1516 ha squared. And lastly, what I need to do is integral of dA, which is going to be h 4a squared x2 dx. Again, when I have dx, bounds of integral are from x, which is a to 2a in this case. h 4a squared, let's bring it out of integral, a to a x2 dx. Again, not too difficult. 4a squared x3 over 3 going from a to 2a, and that will result in 7 over 12. I keep the numbers like this, so when you're doing the math, you can kind of follow the math, and if you make a mistake, you know where you've made a mistake. All right, so let's just plug them back into the equation. Y bar was y tilde dA over integral of dA. The numbers we have calculated, y tilde dA integral was 31 over 160 a h squared over dA was 7 over 12 ah. So this will result in y bar being 0.332h. And then x bar, x tilde dA over integral of dA. If I plug what I calculated on the previous slide here, I will have 15/16 h a squared over 7 over 12 a h or ha, and this will result in 1.61 a. Thank you very much.